So I think I understand Vmax. That one makes sense. Like, it's the fastest velocity you can get as you increase the substrate.
Yeah. So the thing is, it's hard to understand graph kinetics because like we use this model, but really an enzyme might do this, but there might be extra steps on there.
Yeah. More complicated than that.
Yeah, and so like a Km, it's really, we think of it's how tightly an enzyme holds onto the substrate.
Right, okay.
So that's why your Km is equal to K minus 1 plus K2 all over K1. Because your K minus 1 and K2 are how fast your substrate is leaving. I need to put plus P. So it could be either how fast the substrate leaves when it turns into product, or how fast the substrate leaves without it even being changed. K1 is then how fast it gets there. So a really small Km means the enzyme holds on to it really tightly, because that means your K1 is really big. So it's your substrate's binding, but it's so much bigger than the number of values of it leaving.
Right, okay, so your what you want is K2 to be greater than K1, and K1 to be greater than K.
You want your K1 to be greater than the sum of these.
The sum of them.
To a certain extent. Then another one is your K cat, which I always forget. Yeah, is there a mathematical?
It's pretty much the same thing. I think it's right there. Well, it's kind of those two, but I didn't.
There is one that has just what.
K cat equals V max over ET.
Yeah.
The concentration of E total. It's like.
Okay. And so your K cat really is then how fast, once the substrate's bound, is turning it into product. That's the basic idea. Let me.
Now, I know E is enzyme. What is the T?
Enzyme at a specific time.
Is it time?
Or maybe total free enzyme.
Yeah.
But most of your enzymes are going to be bound in with this. It's going to be ES when it's. So, really, the mathematical part probably doesn't help out as much. It's just knowing that cat is how fast you're changing. And then here, they're showing this K cat over Km. And if you notice, all the values come out to be about 10 to the 7th or 10 to the 8th, roughly around there.
Okay.
And so if an enzyme has a really small Km, that means it's binding onto really tight. So it doesn't need a really good K-cat, because a really big K-cat means it's turning it into product really fast. So, but if the Km's large, meaning it's binding loosely, it needs to have a really fast K-cat. So that's why these ratios tend to be around the same value, because if an enzyme has a really good Km, meaning it's really small, it doesn't need a big K-cat, because if it did, it'd be wasting unneeded energy to work that fast.
So these aren't predicted values. These are
Observed value.
values. Okay. So what you're saying is, if something's bound really tight, that's going to affect the K-cat. That's going to affect how long it takes to go through. So generally...
Well, no, if it binds really tight, its K-cat doesn't need to be large, because it could take its time to turn into product.
Right. Okay.
If it goes too fast, it's going too fast for no reason, because it's holding it onto it tightly. Whereas if we had a really big Km, meaning it binds loosely, and our K-cat's small, then the enzyme's worthless, because it just it drops the substrate, but it doesn't turn it into product fast enough.
Turn it over. Okay, so big Km is loose.
Yep.
Okay.
So you want both these numbers to either be big and big or small and small.
Big is loose, and then
Big K-cat is fast.
Okay, yeah.
Turning into product fast.
Bringing it down to like my 8th grade vocab here.
It's fast. And I think once I understood that, kinetics made a lot more sense, because I worked my tail off in this chapter and was like, I don't understand it. But
right.
once I got that idea, it made a lot more sense.
Yeah, it makes more sense because like reading and stuff, it's pretty much all I figured out was KCAT was just like the rate limiting step, which makes sense. But
Well, yeah, I'm
Yeah.
flipping through reading these things, and I'm like, where did that new variable come from? Like, I don't remember reading about this. So.
Because the problem becomes, like, let's say the enzyme, instead of, some enzymes turn it into product but hold on to it, and then go like this. So now all of a sudden you have like this K3, and so now your Km is like plus K3, and so you can see why, depending on enzymes,
Yeah.
like there's not, with kinetics you don't just learn one thing that works with all enzymes. You have to understand the idea, and then you probably have to figure out new equations for each enzyme or type of enzyme.
Okay.
So we just cover the basics, and then once you're done, you like realize, hey, you don't really know anything about kinetics.